Thank you. I want to say first that this talk comes from the experiences I made in past few years, and especially in the Free API project. I will mention the Free API project because that's what's driven this talk, but I hope it will apply it also to a generic way to build identity management system on Linux. A question, how many of you know what it is a management system, an identity management system? A few. And how many of you use one? Okay, thanks. So let me try to define what it is, because the problem is that there isn't a very good definition, and so I try to make my own and then stick to that. So in a nutshell, an identity management system is a set of services and roles that are used in an organization to manage the users. And I use users in a very broad way here. By users, I mean any actor that actually has to interact with identities. It includes information about individuals, what normally are called users in the computer systems, but also about computers, about groups, about the roles of users and groups on computers and networks, about authentication, authorization rules, and it applies also to device managed by the system. And by device, again, I use a very broad definition. It's not just computers. It could be appliances. It could be other smart devices like phones, even, or even just access points, network appliances, network devices. And an identity management system is always used, even if it's not really recognizable sometimes, when you have to handle more than a few machines. Anytime an organization has to handle a number of machines that is about 3, 4, 5, you have to find a way to organize and manage identities and the machines themselves in a network. So it's a very broad definition. And from this broad definition, I'm going to talk mostly about what you can find in a data center or in a company that uses Linux. So let's also define a bit about what are identities. When you see this word, you usually think about users, persons. You might think about official identification documents and stuff like that. But computers, or even programs sometimes, just a single programs, often need an identity of their own. For admins, it's easy to see this when they run an application as a specific user on the system. What they are doing is effectively they're giving an identity to this program because they need to apply some authorization or some authentication to that specific program. And identity is also managed in groups because applying authorization decision to groups is much easier than picking every single user, especially when users are not just people, but even just single applications on machines. So what do we need to manage in an identity management system? At the core, what people really need to manage, there is the user's life cycle, and that is very simple. In the end, it's all about creation of users in the system, deletion, and various status changes, like whether the user is enabled, not enabled, when it starts. Some users go into dormant state, come back later, that cannot be deleted, things like that. The other part, very important part, that's like day-to-day part, is relations. Users are often put in groups. Users have roles, and those are really the reasons why you need users in the system in the end. You need to identify a user because the user needs to have relations to machines and to other users. It needs to authenticate to machines, it needs to relate to other users, need to be able to operate in a way that the computer knows what are the privileges that this user is given so that I can perform the actions that other users may be not able to. And then there are policies about this user, like passwords. Passwords very much used still So you have to try to make sure that users don't use too simple passwords, or maybe in some places you want to have them change the password often for whatever reason. And so you have to manage all this user's life cycle. And when the system is big and complicated, you need a way so that this management doesn't really take too much time, because you have to make sure that all these users can operate on all the machines of the system. Think about administrators in a data center with thousands of machines. You cannot go to every single machine and add the user to the password file. You need the system to distribute this information. You need to make sure that this information is always up to date and applicable to all machines. And that you need to make sure that it is not outdated, because if the information is not propagated properly, you have administrators or even just normal users that cannot access some machines, or users that shouldn't be able to access some machines still can, because the rules have not been brought there. The other part, which is sometimes less evident, is computers' life cycle. Computers, as I said, have identities as well. So computers need to be introduced in the network. I call that enrollment. And sometimes they need to be retired. They have all kind of properties like a name on the network, so the specific system can be recognizable. And all these things need to be somehow managed, because as for users, when you deploy machines and you have many of them, you need a way to identify them in a way that is that makes sense to the user, in a way that is secure, so that you cannot have people bring in or bring out machines without you knowing from the system. Connected to that is the creation or revocation of keys for large network. This could be Kerberos keys, could be SSH keys, X509 certificates, which are nothing else but a wrapping around the key. And this is all just to make it possible to recognize a specific machine in the network. And again, policies as well. You need to tie access control to a machine usually. When you have a very large network, you have quite a number of users, and they're not doing all the same thing. So you may have databases, you may have web servers, you could have CRMs, whatever kind of machines. And there are a set of users that are allowed to use each of these machines. And each user also needs authorization, because some of these users are power users. They can change the configuration of the machines. And even there, these admins might have different levels of authorization. Some admins are allowed to change security properties. Other admins may be allowed to change only some application of the machines. So there's all these life cycles also that goes into managing systems. And there are additionally other security aspects of networking that are more at the network level. Things like simple DHCP and DNS, which are given for granted, still need to be managed and are all security related, because today resolving names is part of the equation. So when you come to the problem of how to manage all these identities, users and computers alike, and you have a very large network, you come to a problem about how do I, what to do? Do I centralize all this management in one system, or do I try to distribute management? And ideally, you would like to be very flexible in how you build a system, so that if the situation changes, you can change the way you manage things. Unfortunately, embedding this flexibility in something that deals with security and with authorization authentication, it's not very easy. So there are very hard choices to make, and often they have to be made well in advance when you try to architect and stuff. You cannot do these changes later. And this problem hits multiple levels, whether to centralize or distribute information. At the networking level, you need to decide how you want to distribute the services that manage identities, so that you can, for example, avoid single point of failure. You would like to have services widespread so that if one goes down, another can take over easily. But distributing information is also in itself a difficult problem. So how do you decide what is the right balance there? Security, centralization tends to be preferred for the simple reason that you want to reduce the attack surface. So you don't want to spread your database of keys or password over too many machines, because then you increase the attack surface. Any of the machine that holds keys that can give access to the network becomes a point of attack. So you have, again, a tendency there to want to centralize, but if you centralize too much, you might have single point of failures. So it's a very hard problem. And finally, centralization distribution also affects administration. You generally might want to be able to delegate tasks to multiple people, and that's a way of distributing the tasks. However, to perform some tasks, you might need quite high privileges. And so again, you need to find a way to balance the privileges you distribute, because the more you distribute privileges among the population of users, the more you increase the attack surface. So being able to finally distribute privileges, delegate only specific tasks to use it helps, as you can reduce the number of things they can do. You reduce also the attack surface for the whole network. So centralization, as I mentioned already, may be interesting for many reasons. It makes management easier. If you have less machines to control, it is easier to control them. It makes reporting about these machines easier. It makes reporting about users easier. It makes enforcement easier sometimes. It makes development much easier. Distributed systems are hard. On the other hand, distributed systems tend to be much more resilient to failure. So how to choose exactly which functions to centralize and how to distribute information is a very difficult choice. And it's something that is not, it doesn't have a fixed recipe for all situations. It's more an art than anything. And you have to choose in your own architecture, or you have to use a product that made a choice for you. But even then, before you can choose a product, you have to decide whether it meets your requirements or not. Scalability, resilience of failure, security, they all go against each other. So next, let's see what are all these functions that an identity management system have to make, and why I was introducing centralization on the delegation of feature. So, of course, an identity management system needs to be able to identify users, and in the computer world that means authenticating users and also services. It has to manage password and other options you might want to consider when you think about it is whether you should do single sign-on, whether you should want to use two-factor authentication. These properties can change quite dramatically the way you can deploy services sometimes, the way you can use authentication applications. So you have to know in advance whether you want to use these features or not. It also generally manages certificates and keys. By certificates, I mean X5 and under certificates. Most of the security on the HTTP protocol, which is quite popular these days, is based on SSL and specifically on the certificates, X5 and 9 certificates that the SSL infrastructure is based on. Keys in many big networks for management, you can use Kerberos or SSH. Here I'm being ambivalent. In both cases, you have keys that you deploy on machines and you use to gain access to them?
Actually speak a little bit louder.
I'll try.
Okay.
Okay. And and you want to manage this. In many Linux development C, you may have a centralized server that does password authentication. Classic services are NIS and LDAP. But then SSH keys or Kerberos key tabs are kind of managed manually, difficult to keep track, especially for host keys. It becomes quite easily a mess very quickly. Another thing an IDM server, in my opinion, need to manage is the authorization rules, access rules per host, and user roles and administration delegation. In Linux, that means sudo mostly. But it also means SC Linux in some cases. And other things that are normally not really associated with identity management, but I think deserve a place in there are the network level, DNS, DHCP, and other things like maybe radius, things like that. Finally, auditing and reporting. I will not talk too much about those. Auditing and reporting are whole arguments on their own, but they are fundamental because if you have a large network, you need to know what is going on in the network, and you cannot base your understanding of what is going on if you don't have tools that allow you to gather logs and audit reports from many machines and somehow distill and filter out what is interesting about them and what is not. Because in very large networks, you have much more information coming in that you can possibly process by hand. And so you really need to be able to deal with this with auditing and reporting in a centralized way so that you can understand what's going on. And what are the responsibilities of the clients instead? And by clients, I mean any machine that is not actively providing an identity management service like authentication, authorization on a central service. So clients, especially Linux clients, need to retrieve information about users, groups, sometimes net groups, roles. It needs to retrieve things like certificates and key tabs when it is instantiated. And there are other configurations like auto-mount maps are common in Unix-based networks. Clients need to perform authentication, even though passwords and keys may be held in a central server. When you authenticate to a client, you actually perform the authentication partly on the client as well, because the client is involved in the whole process of authenticating the user. Authorization is totally done on the client generally. Host-based access control is done on the client. Pseudo rules are applied on the client, even though you might keep this information centrally. It is the responsibility of the client to apply these rules. SSH keys are generally held on the client, and SC Linux user make sense only on the specific client so far. Other miscellaneous clients might do is something like DNS discovery, DNS updates. If you have used things like Windows and Active Directory, you will know that these clients tend to do a lot of DNS updates. And another thing that is very important but often neglected is time synchronization. We'll see later why. So in a nutshell, there's a lot of stuff to manage on a network that I put under the umbrella of identity management. And management tools are extremely important, as important as the technology used underneath. If a system cannot be managed, it can't simply be used. I've done implementation of identity management system in the past that were just simply too complicated for people to use, to the point that when I was not around, they were useless. And the system is completely useless if the administrators cannot use it, cannot understand it. And one of the problems is that in free software, and I've been developing free software for quite a while, management is completely neglected. free software developers are developers first, and they tend to think that everything is easy. And because we do understand the command line and we're very comfortable with it, and we know generally the system very well, we tend to completely overlook the importance of providing management tools for users that are not as proficient, that are not developers. And so we might end up building systems that are not really usable, in my opinion. Security and complexities are intertwined. If the system is complex and difficult to use for the administrator, it also means that it might very easily get insecure. In many systems, you will see people take shortcuts like using self-signed certificates or very simple passwords, sharing key tabs without, over email. And these are all problems mostly due to the lack of management tools for these security, for these important security properties of the system, like using a self-signed certificate is not bad just because it shows you a bad page on Firefox when the user gets there. The problem is that by using self-signed certificates, you train the user and even the admins to just skip the security warning of Firefox. You basically become completely insensitive to that security information. And it's very easy for an attacker then, if you train your user to completely ignore that warning, to create man-in-the-middle attacks. An attacker will not have to care that much that it doesn't have access to your certificates. It will just put a self-signed one and count on the fact that the vast majority of users, when they see the warning page, will say, okay, this is the user self-certificate used by my admin. I will just say okay to Firefox and go on and put my password in. And you're just giving up your password to someone. But the problem with using self-signed certificates is not much that admins are lazy. They are also lazy. But the problem is that there are not very useful tools or easy tools to manage certificates in a meaningful way. And that's why admins tend to, or even developers tend to use self-signed certificates, for example. Same goes for using, for example, sending key tabs in an insecure way. It's not because people don't want to be secure, it's because they don't have tools to sanely manage this stuff, and they try to use the simplest way they can. Other things that are really important are diagnostic tools, because complex systems never work 100% of the time. There's always something that breaks in a very complex system, and you need to know what breaks in order to be able to fix it, because otherwise breakage will compound until something will collapse. And a word of advice, whatever you think of when building these systems, try to keep it simple. Sometimes it's really not possible, and when it's not possible, you have to make it manageable. So let's try to get a bit on something more concrete. How hard can it be to actually build a management system? As most admin would tell you, I just install an LDAP server and I just install a Kerberos server, right? How hard can it be? It's just 2 packages. How many of you have actually installed Kerberos, a KDC? Quite a few. How many of those will do it again? Not many. You didn't like it. Some numbers. In 6 years, part of the free API project, the most important part for me was to build something that was easy to manage and easy to install. Something that would take out the pain of installing LDAP and Kerberos, which you can see it's not just LDAP and Kerberos in the end once you start building stuff. Our installer, for example, makes 96 unique steps to build one IPA server. Might not seem a lot, but if you think that every time you have to install a new server, you have to do 96 steps, and that's not just 96 commands. By step, there are logical units, so it could be multiple commands, like putting up an LDIF file, a schema in the server, then deploying the information in the LDAP directory, then running a bunch of commands to build the certificates and stuff like that. All this could be a single step. And they are a lot. Making mistakes when you have to do almost 100 different steps to build a system is very easy. And in many cases, not only you will waste a lot of time, you may not notice that you forgot something that is critical. So, for example, the free IP project, all these 96 steps take 5 minutes. And that's also very important because admins don't have time to babysit stuff for too long. They have a job to do. They have to actually manage those users. They have to manage those groups. They cannot waste days, weeks to build the systems. Because just building the system is kind of a waste of time because it's not productive. The system is doing nothing. You have machines and resources there that are not actually serving the user. And on the complexity, this stuff is 150K lines of code, mostly Python, that sit on top of all the components used. These 150K lines are not NTP, they are not directory server, they are not the PKI, they are not the KDC, they are just the bits that you need to manage and configure the systems. So it's a lot of code. Because if you think about it, it's not comprising any of the character components. And part of the project, we also built a client, and that's another 150K lines. So it is hard. It is hard, but it is doable. It is doable, and the extent you want to do it depends on what you want to achieve, of course. So this is a picture of what we decided to do when we built free IPA. This is just one possibility for an identity management system. You don't have to do it that way, but we did it this way, and these are the components, and then I can just show a few of them, why they're there. So LDAP is the central directory where all the information is kept. There is a KDC with its KAdmin companion daemon that we use mostly for authentication. There is a CA component, that's PKI, that we use to manage certificates. And then there is a lot of code for the management interface that is built on Apache, so just simple web UI. Finally, we integrate the NTP and DNS to provide services to the network. As part of the project, we also built a client called SSD, and so that's the final component that completes the actual picture. We try to use as much as possible existing components to reduce the number of things we had to do. We try to use standards as much as possible. So why LDAP and Kerberos? Some people come and ask this question, and it's a quite legitimate question. Why are you using those components? Some people prefer to use databases to keep users. A lot of web applications do that. They just build their own database that they use for other data, and they also put the users in there. That's actually managing users, so it's an identity management system. We choose LDAP for a number of reasons, mostly due to legacy and standard adoption. There are a lot of systems that already know how to talk to LDAP, especially when it comes to distributing users on Unix machines. We had a server that was well done and worked very well for multi-master replication, and also support read-only replication, which we don't use in the FreeIPA product. But multi-master for us was one of the deal breaker because we wanted to make it possible to distribute information. Because the problem is that we wanted to build a system that was not only easy to use, but it would scale on a lot of machines. Because we have customers in Red Hat that have quite a bit of machines in the thousands or in the tens of thousands sometimes. So we wanted to build a system that could be used by these people as well. And you cannot build that with one server. You have to distribute information in multiple machines and sometimes in multiple geographical locations. So you need to have something you can put all the data around. LDAP also have, in all the implementations I know, has fine-grained access control in the form of ACIs that you can apply on single objects in LDAP, which is something that you cannot find using in SQL. In SQL, you must have access, for example, as a user, and then you have to build in the application the logic to control the access. While in LDAP it's built, it's there for you, you don't have to do anything. And finally, again, standards-based. We didn't want to invent our own database. We want to use something that is standardized and out there. And so that's why we used LDAP as a database. And some people come and ask, why Kerberos? I mean, I use OpenLDAP and I'm happy. Why should I care about using something like Kerberos? And that's because we wanted to make sure that the level of security could be higher if you want to. The one point that we made in FreeAPI was that you can use LDAP if you want. You can ignore completely the Kerberos part. The LDAP server has the password of the users. You could use authentication. But using passwords has a big problem. And the big problem is that when you use a password, you're basically giving up your identity to whatever service you send your password to. So if you have a web application somewhere that asks for your password to authenticate to the central system, now not only you and the central system have a password, that web application have a password as well. And if that web application is compromised, then the attacker has your password and can access other systems that may have a much higher security profile. So using bare passwords basically weakens the whole security architecture because you are as secure as your worst application. And in most corporate networks, the security of some application is bad, really, really, really bad. If you use Kerberos instead, what you give to application is not a password, is a token, and that token has meaning only for that specific service, for that specific application. So if the application is compromised, it cannot do anything. The only thing the application knows is your identity, so it can authorize you to do whatever you have to do, but it cannot take that identification information and try to use it against other services. So that's why Kerberos is important, even though it's difficult to use sometimes. Certificates can also be used for this purpose. However, the problem with using certificates is that they are much, much harder to manage. They require the user to store information in the form of certificate and carry it around multiple machines, and that's cumbersome. We offer certificates as part of FreeAPI, although not for users, but we didn't choose it as the authentication mechanism because of that, because of the difficulty in actually using these credentials. One other reason we use Kerberos is for scalability. One of the very good points of Kerberos is that because you're using tickets, when you have to authenticate multiple times against an application, you don't have to hit the central server to check the password. Because once you get a ticket, that ticket is valid for an amount of time, usually between a few hours, sometimes a few days. And once you have it, you can just go and talk to the application without having to talk to any central server. So basically, you reduce the load against central servers while distributing it to all the applications. And again, security and standard. We didn't want to invent anything new, especially when it has to do with crypto. Okay, in the image here, I also showed you a CA. That's the certificate authority using a public key infrastructure. But why using a public key infrastructure? Well, the reason is that a lot of protocols use SSL certificates instead of key tabs to secure the connection between the user and the service. A web server uses HTTPS normally, but even IMAP, SMTP, they're much easier to integrate when using SSL because applications at most know how to do SSL in many cases. However, the big problem of using SSL in an organization or a network is that you have to manage certificates. You have to distribute certificates, you have to sign certificates, and that's a very difficult task to do unless you have a component that can do it for you. So we integrated a PKI system in there as well so that all the certificates for all the machines can be easily managed. It's part of the IDM system in our idea. And it makes one thing very simple. If you put the certificate authority certificates in the browser of your machines, then the user doesn't have the warning that a soft-side certificate is being used. You can just access the website just like you do for a bank or for whatever, Google or anything. They have a certificate signed by certificate authorities that are recognized by your browser. By inserting your own CA in the browser, you do the same for all the machines in your own network. And you don't have to go and train user to ignore security warnings. And DNS, why DNS is crucial and why it is important to integrate it. So all the services you have in a network basically use a name to be recognized. When a user wants to access a server, doesn't know anything about IP addresses. It knows at most a name when it knows it. X509 certificates, they work only with names. You have to put a name in the certificate and the machine has to keep that name. SSH keys, if you look at when you do an SSH to another host, it will identify the key and associate it with a name. SSH also associated with an IP address, but IP addresses are basically obscure. And also because IPv6 is coming, at some point it will come, and it's really impossible to remember an IPv6 address. They're just too long. And although DNS at the moment is insecure, even though it's useful for all these things that are involved with security, like SSH and 509, there are mitigation coming. DNSSEC is having a decent adoption, slow but decent. And there are ways also to handle DNS updates from machines in a secure way using PSIG or GSST6, which is what we use in FreeAPI. So even though DNS is insecure in the normal case, it can be made secure, and that's one thing that we haven't done completely yet. For example, in FreeAPI, the DNSSEC part is very complex, but we're planning to do, and something that everybody that is deploying DNSs these days should really think about doing. Another component that is really neglected, and that's why I want to point it out, is NTP. NTP is the network time protocol, and it is critical for a lot of things. In our case, it's critical especially for Kerberos, where there is this famous Kerber 5 clock skew, because we don't want to have tickets to use forever. One of the things that are done when you're checking a Kerberos ticket in application, that's done by the libraries underneath, is that the ticket is checked for time. If you're trying to get a ticket and the request you're sending is not within 5 minutes between the client and the server, the request simply drops. You're not allowed to do that. And that's used to avoid reply attacks and things like that. But it's also important for many other processes. For example, log correlation. As I said before, one important thing is when you have many, many machines, you really need to be able to gather all the logs. But gathering logs is important also for log correlation. You want to understand what is going on. You want to be able to correlate that client 1 is failing when server 2 is also failing. And if time is not kept in sync on all machines, That's not easy to do. You will have one machine that thinks it's 1 hour, and the other machine thinks is, one machine thinks 1 p.m., the other machine thinks it's 3 p.m. When you try to correlate logs, you will not see that they are actually having a misbehavior at the same time. And that is particularly important in security when analyzing access pattern and stuff like that. And there are a bunch of other services that we haven't integrated in FreeIPA, but might make sense to in some cases, like DHCP, Radius. Radius is an authentication server, maybe even telephony, why not? A lot of people are implementing SIP in their companies, and the phone is as much as identification as anything else. When you want to call a person, you use a phone. And there are a lot of attacks going on in the wild against SIP phones, because SIP phones are fully managed systems. They are actually computers. They just run a very specialized application, and you can attack a SIP phone and then use it to gain access to the network. And that is being done. So it can be seen as something to manage as well. I'm sorry if this is not of your liking, but I want to stress that a management interface is fundamental and is one of the primary things we've been developing in FreeIPA. It's really a fundamental component. You could have technologically the best thing on earth. All the components might work perfectly, but if you don't have a way to manage this system cohesively, it's useless. I can have hundreds of LDAP servers, but if I'm the only one that knows the LDAP command line and the other in the company can't, you're making a single point of failure of the people that designed the system and built it, because nobody else can use it. So if you think about building a management system, I recommend thinking about things like network APIs. You want to make life easier for admins to actually be able to use this system, and for them, use this system means also being able to pilot the system from their own, for their own reasons. We have had a lot of people come to us and ask, how can I create users from this other machine foo that HR uses and contain all the users that HR know about? We want to bring all these users on the Unix machines, but we need a way to connect these two systems, and an API is fundamental for that. Sometimes you can get away with command line tools for that. The administrator can cobble up an SSH onto the machine that calls a bunch of scripts, but if you have an actual API, it makes it much easier to integrate. And although it's completely not mandatory, a graphical interface really helps, especially when you have to deal with people that work in things like help desk or managers. It makes the system usable by a much larger number of people, empowers them to do operations without having to contact more knowledgeable people, and you free more knowledgeable people to work on what matters, building more systems, low-level management. You don't have to do things like resetting passwords for users. You don't want to use an admin that is very skilled to reset a password for a user. You want to have someone else, like the user manager or a helpless person, to do that. And you have to give them tools, because otherwise they cannot do that, because they cannot really understand very easily how to use a command line interface in most cases. So this is just an example of what we built. It doesn't have to be really fancy. In our case, it's just a number of menus you go through, but it has to be really effective. You just have to show and allow you to do what you need to do. It is usually just creating some sort of grouping. Could be users groups, could be roles, it could be groups of other rules, and then have a way to associate users and machines to these groups. That's all it is, really, in the end. DNS is slightly different, but it's not really difficult. From my point of view, kind of boring. I didn't do it. But it's really important for the actual users of the system. When we show this interface, the admin, to our customers even, they are really happy because they can do what I just said before, give access to less knowledgeable user to do operations without tying up resources of very knowledgeable ones. So this is for the server, all the components. On the client, servers are important, but if the client can do something, there isn't much use in putting up a server infrastructure. So what can the classic Linux client do? That we used as a base to start with FreeIPA 6 years ago. 6 years ago, the situation was that a Linux client can use an SSLDAP or other things like NSSLV or a number of NSSLDAP-D, which is descendant of NSSLDAP. Although generally these tools, or these NSSLDAP was built to retrieve information without authentication from LDAP. So just, I connect an LDAP server without encryption or anything, and I pull information. Key management on Linux client manual. There are no native tools to do any kind of key management. If you generate SSH keys, you have to build your own scripts to distribute them. Key tabs are the same, use key admin. Most laptops have been traditionally very hard to integrate when using things like NIST and LDAP, mostly because there was no real decent offline support. So if you have a laptop, most of the time you have a laptop because you travel, you move, you don't want to have to be tied to the network. But with a classic Linux client, if you detach the laptop from the network, you will not be able to authenticate anymore when using LDAP because the LDAP server is not available. And so solutions were things like, okay, we create a local account on the laptop as well, so when you're not on the network, you can use that local account. But you're bringing back all the management issue by doing that, because now you still have to have all the scripts that pull the information from some system and create this local user. Access control also very difficult to manage. There are no good tools. There are things like PAM access, maybe for those that know it, but still requires additional management infrastructure to distribute configuration files, and same for sudo. So one of the things we had to do in FreeIPA, and this is the only development we did for one of the components, was create SSSD. It's, I think, 4 years old now, 150K lines of code. What does it do is that it solves a number of issues that were not solvable a few years ago. One of them is to use a single authenticated connection to a server. With NSSLDAP, unless you use an SCD, you have a bunch of processes that need to get data from LDAP. Every single one of them will open a connection to the server. So if you have 100 processes on the system, you could conceivably have 100 connections to LDAP for a single system. And if you have 2,000 systems doing that, that means 100,000 connections to a server. You are going to kill that server. So we wanted a daemon, not a simple library that is embedded in every process on the system that could handle that. Another very important part was caching of information and identity. That resolves very well the laptop case, but it's not the only reason we did that. We did it mostly to also avoid loading servers. If you can cache information locally on the machine, you don't have to query the central server so much. And if you have to reboot the central server because you're doing maintenance, you're not going to disrupt servers that might be very critical. They have the information cached locally. They can survive for a few minutes or hours, even if the central server is down, if they can cache information. If they cannot cache information, as soon as the central server goes down, you might start seeing outages in the services you're providing, and that's really bad. Then we started adding something like offline authentication. Again, this is useful for laptops, but serves all the life. And other things like host-based access control, pseudo rules. What we do is that we can pull this information from the LDAP server and make it available to the client without having to create your own scripts. You just configure SSD ones and it keeps working like that. Server affinity and DNS updates are other very important things. When you join a machine to a free API server, these machines can automatically update the DNS so that the name you gave it is automatically made available to everybody. Okay. Last slide because time is up. Building an ADM system is very hard. And it's more of a process in the end than a product. My side is to build a product, but it doesn't end there. You have to implement it. So there's a whole process going through defining what are the needs of the organization, what you can do to what you want to implement, what you want to use, how you want to use it. Installing the bits is just the first step. And the other very important thing is that an IDM system must make things easy to manage, otherwise it really is useless. And again, I insist, management is the fundamental part. Homegrown systems have been used so far. I personally think that is a bit of a wasted time to build a homegrown system these days. But if you think that your situation requires something that you have to build on your own because none of the available system gives you enough, try to follow a couple of very simple rules. Use as many components as possible. The more you have to develop yourself, the more you have to maintain yourself, and maintenance is very expensive. Choose wisely. If you choose the wrong component, changing later can be very difficult due to network effects. All these systems are exposed to clients, and if you have to change them, you might have to change also the clients that could prevent you to do that. And look around you. A lot of people have solved problems. Some of them have built solutions like us. Others have simply solved the problem, but put information out there. So look around. Okay. That's it. Yeah, I guess, I don't know if there's time for questions. There's nobody else after this talk, right? There's nobody else after this talk. There's another talk after this one.
Is there?
I don't think so, right?
No.
Okay.
This mic should be okay.
Hi, thank you for your talk. Identity management is clearly one of the areas where Microsoft is doing a lot better since they understood very early some of the things you explained, like good management interface and tightly integrated components. And there are still some very critical pieces missing in the open source stack, like the example I have in mind is that OpenLDAP objects cannot expire, which is crucial when they contain authorizations. Authorizations should always expire. It is a security basic concept. And you cannot make them expire, so you have to use a configuration system, an external configuration system, so you delegate this checking to the client. And anyway, this is just an example, but do you know if there is some effort to implement the missing parts of identity management for Linux?
If I understand correctly, what you're saying is that there are a number of things that expire, like certificates. Are we going to build something that manages that? Is that a question? Yeah.
Can you talk louder, please? I didn't understand.
If I understood correctly, what you're saying is that there are a number of things like certificates that expires, and that affect the way infrastructure are managed, whether we do something for that in free IPA. Is Is that the question, or whether do I have advice for
No,
that?
there are objects that should expire like sudo rules, and you cannot make them expire directly in the directory.
Well, sure, you can make everything expire. The way we've done that with our free API, we have rules that where you can put an expiration time on. The point is whether the clients respect that rules. In Linux, with the sudo nap, there is a sudo nap before, not after rule, and it is respected. But it depends on the client whether it respects that or not. For certificates, for example, in free API, we have a service that can renew certificates because certificates do expire. So we have built knowledge in our system about these problems. Same with Kerberos tickets. They do expire eventually. So we have built some tools in the client to allow you to handle that problem or that annoyance correctly.
So you add that functionality outside of LDAP itself?
Well, the information may be in LDAP. The problem is that the enforcement of the information necessarily depends on the users of that information. The LDAP server itself cannot really do anything to the pseudo binaries. The pseudo binary need to respect the information and other tools as well.
Hello. I actually have a couple of questions, but maybe I'll start and you can interrupt me when it's too much. So for start, is it possible to integrate the free IPA certification authority to use the HSM?
HSM?
Yes.
You mean for the PKI?
Yes.
So the PKI we use is DogTag, which is the open source upstream project for Red Hat certificate server. DogTag does have HSM capabilities, but we haven't integrated them in the free IPA product. In order to make it possible to easily install free IPA, we had to simplify some things. So not all the features of the underlying products are always available now. They might be in future. The way we handle people that have needs like HSM is that we advise them to install their own PKI, for example, for user certificates that we don't provide through free APA, and then make free APA a subordinate CA and use it only for the certificates that are distributed on machines, like web servers, or for use for IMAP or VPN, stuff like that, only for device certificates.
Okay, the second one, you mentioned auditing. So how is auditing currently implemented in free IPA? And do you support some kind of integrity checks and...
So the auditing part is not really well developed yet. We started the project within the free IP project itself to do auditing better. However, there are so many moving parts at the moment in the Linux landscape when it comes to auditing. A lot of concurrent projects were started both within Red Hat and outside of Red Hat in the community that made it really difficult to choose a good component. And so we decided to actually postpone an integrated auditing system. We still have that on the radar, but we are a bit on the lookout. At the moment, every single component does its own login auditing, but we don't have an aggregator, which is really important indeed. But we don't have that yet in FreeAPI.
So you mentioned that you recommend your customers to use a dedicated CA if they want to use the HSM. So can you tell me, is it easy to replace the CA component in free IPA? For example, if I want to use EGPCA as a CA provider.
Once installed, it's not easy to replace it. So if you're going to try free APA and your plan is to use it as a subordinate CA, you should do that, when you install it. When you install it, you should make it a subordinate CA at that point. However, there is we can actually renew certificates in there even for the CA. So it's not impossible, it's just not easy. But the problem is that once you have a whole lot of certificates out there, and if you're going to change the CA, you know, it's not an easy problem to solve. The way we are going to solve it, it's not fully solved yet, is by making it possible to rotate the CA and have the client tools pull the new CA in a way that you can keep two CAs going side by side until you recycle all the other certificates. And then you finally remove the old CA certificate from the client and just use the new one. But it is a process that requires time because you have basically you have to renew all the certificates on all the machines. At least if you want to remove the old certificate, you may just leave the old certificate and start using the new. But the problem is that with SSL, you need to have revocation. And so you cannot really just abandon the previous one. It's a hard problem.
I understand that this particular project is, let's say, dedicated around identity management on provisioning accounts and authorization on Unix systems, mainly, on the other side, my question is, do you think there is, or maybe it's already in progress, the idea of extending this, the framework, the work project to what is, for example, to let it more near to other identity management solution, even if not open source, like that could implement business process or provisioning accounts also to other systems that are not strictly Unix related, like databases or subsystems or other stuff like that. Just, for example, IBM solutions or Novell solutions, OpenIDM or Oracle Identity Manager, those kind of functionalities.
Sorry, I didn't get the question yet. The audio here is a bit bad when public make questions. So can you try to make a very short question and speak lively as well?
Yeah, okay. My question is, do you think if this project is only related to identity management of Unix account, or there is also the intention to extend it to other systems in the future and to implement other functionalities for business related?
The question is clear now. Yeah, so our focus is primarily Linux machines, very focused on that. Because of the way we use standards, other Unix machines can very easily be integrated in. We've done Solaris and even AAX back in the time. macOS, there have been some users that contributed documentation. If you're thinking Windows, the answer is sort of. The problem is it's too long to explain in an answer, in a Q&A. So maybe you can come later and I can explain to you. We have a way to deal with Windows side, but we decided very explicitly not to try to manage Windows machines directly.
Okay, thanks.
Okay, ladies and gentlemen, unfortunately we don't have time for other questions. This was the last talk in the Jensen room. I'd like to thank you all for coming.
Yeah. Thank you.
Before everyone goes, just point out that tomorrow